Okay, guys. Once you are here, you let me know so that we can start. Kindly let me know through the chat box so that we will start. Those that are here, let me know through the chat box. So I will start sharing my screen now. CIT303. Just so done, I will share my. I think we can still recall what we did in the last session when we talked about data communication. Talk about the. Excuse me. We talked about the topologies, but those topologies we just check the types we have. We did not talk about the short definitions, like what is star topology, what is mesh topology, what is ring topology, what is bus topology. We did not talk about all those. We only treated the types we have. We've talked about the component of. Okay, let me share my screen, please. I think. Okay, Theophilus, you're welcome. I'll share my screen now. So let's start. Anybody that is not here, that is their own issue. We don't really have time like that, and we have a lot to cover before the exam starts. Okay, so once you're able to see my screen, Theo, please let me know. I think I will need to join here too so that I can follow up. So we'll not be wasting our time today. We'll just be going straight to what's it called? The exam focus. Important things. No need for stories. Important things. That is what we are concerned about. It will show. It will show. Hold on. I think I know why it's not showing yet. Okay, it should be showing by now, I believe. So we are good to go. Okay, now since we can now see it, I think we should go straight. Uh, Let me quickly do a short recap of what we did in the last class so that we will not forget. In the last class, we talked about the definition of data communication. And if you can recall what we talked about then as the meaning of data communication, which is the module 1 and unit 1 of the course material, we were able to talk about it is the communication between devices for the purpose of exchanging data. Data communication is the communication, interaction between devices. We said that the devices cannot, it is not necessarily uh, computers, printers, router, anything in the network. So the exchange of data between devices is called data communication, or the connection or interconnection of devices together for the purpose of sharing data is data communication. So in your own definition, you don't need to write, all of us here don't need to write the same definition when we're asking the exam. So if I am choosing data communication is the exchange of information or exchange of data between devices, another person should write data communication is the interconnection of computers or interconnection of devices together to share data. So we should not all write the same thing. When you are given a word, you should be able to process it in your own way and write it in your own way. So that is what it means that you've understood that thing. So that is the definition. But we said for that thing to happen, for that exchange to happen, exchange between a device, which is the server, and a device, which is the receiver, the sender and the receiver, there are things that are components, the things that must be in place for data communication to take place. And those things, there are 5 in number. We have message, which is that data that you want to share must be there. If you want to share a file between your phone and your PC, you understand, the file must be there first that you want to share. Then the sender, which is if it's your phone that is sending it to your PC, your phone becomes your sender. If it's the PC that is sending it to the phone, the PC becomes the sender. Then the receiver, which can either be your PC or your phone, and then the medium that you want to use. Is it data cable you want to use? Are you using a USB to connect the two together to share the data, or you are turning on Bluetooth to use for sharing? That is the medium. Then the protocol is set of rules that must be obeyed for the transfer to be successful, to be possible. So there are a set of rules that must be obeyed for that transaction to be complete. If the rules are not obeyed, you may be sending the message and it will go and land on someone's SPC. But there are some protocols that will guide the process that will make it successful, so that when you send a file from your phone to your PC, it is that same file you sent that will enter your PC, or that will be delivered to your PC, and the same time it's supposed to deliver, it will deliver. So all that falls under protocol. So in case you are asked to list and explain the 5 components of data communication, those are the 5 components and their short explanation. The message is the main thing you want to send, the data. The sender is the person sending it, or the device sending it. The receiver is the device that is receiving it, and then the medium is the channel that you use in sending it. The protocol are a set of rules that they must obey to be successful. It's as simple as that. You don't need to write long notes, just know it. Then we have characters of data communication. The ones we just mentioned, the 5 we just mentioned, those are just components, the things that must be in place for data communication to take place. But how is the nature of data communication? What are the behaviors of data communication? We have delivery. And under delivery, I believe you guys have seen that under delivery, that is making sure that the thing you sent was delivered to the place you are sending it to. That is delivery. Accuracy is also there. We've talked about all this but I think that accuracy, making sure that the exact file was delivered at the exact same time that it's supposed to. Okay, that one is timeliness. Delivering at the right time is timeliness. Accuracy means it's the same file that you sent that was delivered. Jitter is mostly used on video, not only video, but making sure when there are delays in your transmission, maybe through your channel is having some fluctuations. Jitter is a kind of how did we put it that day? Is it alteration or the jitter? Okay, variation in packet arrival time is the variation in the packet arrival time. The jitter, that is variation, the differences in the time in which your packet or whatever you are sending will arrive, based on some inconsistency in maybe the channel or network or anything. So please, let's understand them. The timeliness means that the data must be delivered in a timely manner. Accuracy means that it must be delivered accurately. Data must not be altered. If I'm sending a 5 MB file. It must be a 5 MB file that will be delivered. So I think that is enough on data communication. Let's not waste time. We've done this. I'm just refreshing our brain. Then the next thing we went to was, which is the second most important topic that is always visited every semester, is topology, network topology. That is a kind of arrangement, a kind of structure in which data communication can take place. So if you have an office, you may decide to use a type of system of arrangement of all your computers that you want to be communicating together. So that is topology. Then in that topology, I think the idea we communicated the other day was that is a kind of structure. Is a kind of structure. The network topology is a kind of structure that you put in place. But there is something we failed to do that day. We only talk about the types of topology that we have. We did not talk about, what is it called? Their short definition, how to define them, what each of them mean. So that is what we'll be going to today. And don't forget that we said that we have two types of topology in terms of forms. We have the physical and the logical topology. The physical and the logical topology. The physical and the logical topology. Don't forget, please. Okay, so let's quickly read about protocols and standards. I think let's read about protocol and standard in case we're asked. No, that will be jumping. Please, let's go back to network topology in the material. Let's quickly read through that, please, and read short note on each of the topologies we have. We have the bus, the ring, the mesh. We have the tree topology, and so on and so forth. So, but each of them, we have different definitions for them. So it's very important you know what each of them means or stands for. Fine, I'm there now. Sorry, I will share the screen now. But let's quickly refresh our brain on the network topology. Let's quickly refresh our brain on the definition, because I know some of you were not in the last class. So let's quickly refresh our brain. The network topology defines the way in which computers, printers, and other devices are connected together physically and logically. So that is the meaning of network topology. It's just like a structure. The structure, like now, if you want to build a house, you may decide to build a 2-story building. Your neighbor may decide to say it's duplex the one. Another person may decide and say, I just want 3-bedroom flat. So, but each of us, we are building houses. So that is the idea. Each house with its own structure. That is topology. That is network topology. So when you go to office A may be using bus topology, whereas when you go to office B, even though they are doing the same kind of thing, but office B may decide to adopt ring topology, because we have different type of structure. Just like we have different type of building structure, that is the same way we have different type of structure in network topology. So you can decide to adopt any, but the type you will adopt is dependent on some factors. So when we get to the meaning of each of them, like when we get to the meaning of ring topology, bus topology, mesh topology, tree topology, and the rest of them, you now know, okay, so this is the reason why this office is choosing this one, why that office is choosing the other one. Okay, just know the definition. Very simple. It's just like a structure in which you use in connecting each of the devices on the network together. That is all you need to know. You don't need to cram this whole grammar that is there. Just know that network topology is like a structure, a design, a system of arrangement in which all devices that are on the network are what? Interconnected together. How they are interconnected together. So that is network topology. So when you're asked to define it, you can put it in your own way, but the main idea is that it's just like that structure. Just use this, my idea of buildings, to remember that everybody can decide to build different type of house structure depending on their taste or resources they have. Now, network topology. Network topology has two types, like I've mentioned earlier, physical and logical. Don't forget, if you're asked, what are the mention the two types of topology we have? The types, network topology we have. The types we have, it can be done physically and logically. Then the examples, which we have done this before in the last video, I'm just refreshing our brain. We have the bus, the star, the tree, the linear ring mesh. Then we have some that are basically common. Then this is a very simple explanation here about the design or the topology. They say think of a topology of a network's virtual, as a network's virtual shape or structure. The best way to just remember is using building. When you hear topology in the exam, when you see it, just remember building. Then when you remember building, start thinking of building in this way. The building that Theophilus will build may be different from the building that Fatima Yakubu will build, based on maybe what they want, their wishes or their taste, or based on the resources they have. If Theophilus is having 30 billion now to build a house, he may decide to go for a very Blanfonian building, a very massive mansion. But if Fatima is putting aside 25 million now to build a house, he may decide to go for just a 2-3 bedroom flat and build that thing. So the things that are involved, resources that are available, will also determine the type of topology they will use in an office. So as an IT person, if you are to visit a company now and they want to set up a structure of their network, their system connection, their network, you will first check, what do we have on ground? What are the resources they have? How many systems do they want to put in each office? Or in total, how many systems will be connected? How many routers are you using? How many printers to be connected? So each of the devices, the number of devices available, the resources available, will help you determine the best topology to use. So that is all about topology. The shape does not necessarily correspond to the actual physical layout. So that is it. Now, the major type of topology we have the bus, the ring, the star, the tree, and the mesh. Don't forget, BRSTM, bus, ring, star, tree, mesh. Those are the major types of topology we have. Now, the thing we failed to do in the last class is that we did not talk about each of them. We only listed them like this for your perusal. So now let's talk about the meaning of each of them, so that if the question did not say list alone, if the question say list and explain the basic types of topology we have, you understand, you will know what each of them represent. Now, in bus topology, we have the diagram. I've explained the diagram in the last class. The diagrams are very simple to remember. If you are asked to draw in the exam, each of them, there is a diagram, there is a logic they use in representing them. And for bus topology, okay, let's read through before I explain the diagram. For bus topology, we have that bus networks, not to be confused with the system bus of a computer, use a common backbone to connect all devices. A single cable, the backbone, function as a shared communication medium that devices attach or tap into with an interface connector. A device wanting to communicate with another device on the network sends a broadcast message onto the wire that all other devices see, but only the intended recipient actually accepts and processes the message. Ethernet bus topologies are relatively easy to install and don't require much cabling compared to the alternatives 10 base 2 ThickNet and the base 5 ThickNet. Both were popular Ethernet cabling options many years ago for bus topology. However, bus networks work best with a limited number of devices. You see now, this point alone already tell you that when you want to set up bus topology, you must make sure that the resources available, the number of devices in that office, they are not much. If they are much, it means bus topology will not work. Why? Because don't forget this point. When you are, in case they ask you to write short note on bus topology, you'll be able to add this key point that when the number of devices are much, bus topology is not the best option. So bus networks work best with a limited number of devices. So if more than a dozen computers are added to a network bus, performance problems will likely result. In addition, if the backbone cable fails, the entire network effectively becomes unusable. What they're trying to say, the reason why, just now let's use the diagram for you to understand, because don't be surprised, they used to ask you to draw too. This is POP, not e-exam. Drawing may come out. Now this is the drawing of bus topology. For us to understand it better, let's do this. All those definitions they've given us above about bus topology, that there is one single base or backbone where all other computers on the network are attached to, they are tapping into it, they are getting their data from it. Now, the reason why, if there are so many connections, so many devices attached to this single cable, is that it's only one single cable that is carrying the main connection. So if only one single cable, if there are so many devices attached to it, it will get tired along the way. So if it's sending, let's say it's sending data from this side now, from the left to the right. Let's assume it's sending data from the left to the right. By the time we get to, this one will be getting very high frequency connection. This one too may get good connection. This one may get good connection. This one now, the connection will be reducing along the cable, because once the connection is too long, once the device is tapping on it are too long, the cable will become tired. So that is why bus topology is not good for many devices. When the devices are much, you cannot use it. So don't forget, in bus topology, we have just single backbone. That backbone is the main cable carrying the data cable. So the computers are now connected to it. Each computer each device on the network is connected to that cable. So it's only one single cable that is carrying the network. That is why it is not totally efficient when the number of devices you want to connect are much. So this is the idea of bus topology. Use something to remember bus topology. It has only one backbone. So, and that backbone, each computer, so when they ask you to draw it in the exam, just draw one straight vertical line and then put devices, maybe up and down or anyhow you want to do, but just make sure it's one vertical line which represents one backbone, one main cable. Then attach devices to it on both sides. That is bus topology. You have finished drawing it. You don't need to draw. In fact, when you are drawing in the exam, it's not by force to draw computer like this. You can use boxes to represent devices. You can use box, the symbol for printer, the symbol for, now you can draw devices. I wish I can draw here. I would have shown you. Just use box for computer. For printer, you can draw box, draw small box on it, and then one dot, like the way we represent all those symbols in our program. So that is for bus topology. Don't forget key points under bus topology. When the number of devices are too much, it will not be efficient. And then because of the structure, if more devices are added, there will be issues in the network. The network will start fluctuating. One side may be working well, the other side will be having issue, or the O. And then one short form of bus topology is that if anything should happen to that central cable, that cable that all of them are connected to, then all the computers will stop working. So if the cable should get broken in any part, then all the computers connected, they will not work again. The connection will not work again. That is the disadvantage of bus topology. You should know that, because every other thing is just like saying you are putting all your eggs in one basket. For that bus topology, it means you are putting all your eggs in one basket. So if the basket should crash, all the eggs will get broken and destroyed. So that is it. Then the next topology we'll be talking about, which is the next structure, is the ring topology. In a ring network, now let's observe the structure of a ring network. You can see that the ring is different. This one is in form of a circle. You understand? So when you are drawing it in the exam, if it's ring they ask you to draw, all you need to do is draw a circle and put devices along the circle. That is how the connection. But let's read about it. How is this connection created? Does it have shortcome? What is it best for? Can it take so many devices, or is like the bus topology? In a ring network, every device has exactly two neighbors for communication purposes, All messages travel through a ring in the same direction, either clockwise or counterclockwise. A failure in any cable or device breaks the loop and can take down the entire network. To implement a ring network, one typically uses FDDI, that is SUNET, or token ring technology. Ring topologies are found in some office buildings or school campuses. This diagram illustrates the ring network topology. Now, excuse me, a ring topology such as FDD or SONET sends messages clockwise or counterclockwise to the shared link. This one too is having a similar shortfall like the bus topology. A break in connection will lead to the break of the whole system. Now look at it. So when you are drawing the ring topology in the exam, make sure the position of the devices, they are opposite each other. So if you want to draw 6 devices on the ring, you must place them opposite each other. So this one must be facing this one. That is the way the ring works. If you read what we just finished reading now, and then don't forget that the ring, it can send messages either clockwise or anti-clockwise. So messages can start from this my nigga here. The messages can start from this my nigga here. This my nigga I'm showing now. Okay. And then travel like this clockwise. Or it can start from this same nigga and go like this, backward like this. That is counterclockwise. So that is for ring topology. And one main shortfall of ring topology is that if there is a break in the connection in any of the loop, because each of them becomes a loop, since they are opposite each other and they are communicating, it can lead to the break in all of the connection. So that will take us to star topology. The diagrams are easy to remember now, because for bus topology, one straight line, then devices attached. For ring topology, a ring, a circle, then devices attached opposite each other. You understand? Very simple. Then for star topology, let's look at the diagram first. Star topology is very easy, but when you look at the diagram, you see that there is individual connection of device to a particular central device, which is the source of data. So this one is telling us that, I think for star topology now, the story will change. It will no longer be when the cable is broken, everything is broken. Since every device is connecting with a cable directly, each device with its own cable. Now let's read about it and then get the main picture before we come back to the diagram. If you ask to write a short note on star topology, what will you write? Many home networks use the star topology. A star network features a central connection point called a hub. That may be a hub, switch, or router. Devices typically connect to the hub with unshielded twisted pair, UTP. The full meaning of UTP, if you were asked in the exam, is unshielded twisted pair. This is what I'm reading now. Unshielded twisted pair. That is the meaning of UTP, the Ethernet. Now, the star topology is very sweet. When you look at the diagram, when we observe the diagram, it's like only your big Wi-Fi, your router, or anything you use in your house. Then your sister in her room connects to it. Your brother in his room connects to it. Your father in his room connects to it. Everybody in the house connects. You understand? Individually to the router. So if I'm ready to sleep in the night and I don't need to connect again, I will just switch off my own Wi-Fi in my room there. Whereas the hotspot is still on generally for the house. So individually, one can decide when to leave the network or when to join. That is the sweet part of the star topology. The central connector is there. Each device connects to it on its own individually. So any break in any network affects only a single device. Let's read more about it. If we are to make a comparison between the bus topology and the star topology, we can say that a star network generally requires more cable, but a failure in any star network cable will only take down one computer's network access and not the entire local area network. If the hubs fails, however, the entire network also fails. Now, if you are to write on star topology, this is something, is an important key point you should put in that shows that you really know it. You should know that in star topology, due to the nature of the connection, each computer is having a cable connecting it to the router or the source of which is the hub. Don't forget the hub in this case is the source of the connection. So each computer, each device in the house, each phone is connecting directly to the hotspot. You understand? So if anything happens to any phone, the phone switch off or the Wi-Fi got off or the cable connecting a particular computer to the hub is broken, it's only that computer that will be disconnected, not the whole house connection, like in the case of bus. You know, if it's in the case of bus topology, where everything is connected using one cable, if anything is going wrong with that cable, the whole connection will crash. But in star topology, it's only that particular system whose connection is having issue that will get broken. The rest will still be working. The only thing that will cause a total crash or a total breakdown is when the router that you are using, the hub, the source of network itself is the one having issue. So for instance now, if you are using a router in your house and it's run out of subscription, you know that everybody connecting in the house will not be able to use the internet again, because it is now the main source that is having issue, not that your own Wi-Fi is off or the computer cable is broken. That is the difference. And to remember the diagram for ring topology is very simple. Since you already know what ring topology means. Okay, thank you. Since we still have a lot to, I know, and we still have time a bit too. So since the star topology is like this, each one is connected. I just want you to understand that is it. Once you understand, no matter what they ask you, you'll be able to do it. Okay, so for tree topology, the tree topology, look at the design. The tree topology is a combination of many star topology. That is a simple thing. The tree topology is a combination of many star topology. So when you combine so many star topology, so you have many sources of internet or connection network in the house. So maybe 3 rooms will connect to this particular Wi-Fi. 3 rooms will connect to another particular, like in hotels now, you may use the what do we call them now? The receptionist side may be connecting to just one network. Each room, all the rooms connected together, be connected to one network. Maybe the offices, so like that, we have several star. So a tree topology is a combination of many star topology. It's as simple as that. For mesh topology, where is the mesh topology now? Look at the way the mesh topology works. So let's read a bit about the mesh topology, because a mesh topology involves the concept of routes or routes. Unlike each of the previous topologies, messages sent on the mesh network can take any of several possible paths from source to destination. Okay, now let's see. Let's read more about it here. A mesh network in which every device connects to every other is called a full mesh, as shown in the illustration below. Partial mesh networks also exist, in which some devices connect only indirectly to others. So we have 2 types of mesh. We have the full mesh and the partial mesh. For the full mesh, this is the connection. You can see that while this computer is connected to the hub, the source of the network, it is also connected to the next computer. That one too is connected to the next computer, which is also connected to the hub. So the connection is now 2 ways: computers to computers and computers to the hub, the source of connection. So this one is totally different from all the ones we'll be talking about. Don't forget the mesh. Every device connected to each other through cables and also connected to the hub. So that is the logic. So I think we are done with topology now. Let's go back and see the next important topic we are meant to cover. So far so good. We have talked about data communication, which is a topic they repeat every semester. and then we'll talk about topology. Let's go to the next thing we are expecting. The OSI model and the TCP to IP is also an important topic which we must cover. So that is the next thing we are going into now. Let's quickly read and see what we can grab there. And what are the main things they normally ask? They ask us about the functions of the OSI, the 7 layers, the function, and then the TCP and the IP layers. And then they also ask us to mapping between the OSI and the TCP to IP. So we will go to the material and read about that. We'll go to the material and read about that and see what we can get. Okay, as soon as we're able to see my material, let's move on. We're now on the OSI physical layer. We're talking about the signaling sub, the list of physical layer services, the layer example, hardware equipment, and the rest of them. Now, the open system interconnection reference model, OSI reference model. So the meaning of OSI is open system interconnection. So let's not forget that one. It's very important too. You may try to test abbreviation sometimes. Open system interconnection, OSI. So it's an abstract description for layered communication and computer network protocol design. It was developed as part of the Open System Interconnection OSI initiative. Okay, what is the definition? That's what we are most. A layer is a collection of conceptually similar functions that provide services to the layer above it and receive services from the layer below it. Like, it's just like you have sub layers. This is in between that. You have layers. When you say layers, nothing's arranged like one is on top the other. So they provide functions to each other. So the one above provide function to the one in the middle, while the one below it is also providing function to it. So on each layer, an instance provides services to the instances at the layer above and request services from the layer below. For example, a layer that provides error-free communications across a network provides the path needed by applications above it. I think we've seen the picture of a layer. When they're saying a layer, you lay something above something and then above something. So when they want to communicate, the one that is below will be sending message to the one that is in the middle, while the one that is above will also be requesting message from the one that is in the middle. So that is the idea we are trying to pass. So let's quickly go to the important things here. We have the physical layer. And what is the physical layer? The physical layer is the first and lowest layer in the 7 layer. We have 7 layers actually, I think, in the OSI, that is Open System Interconnections. We have 7 layers, but the first one is the physical layer. I think, is there a place where they give us the list of the 7 so that we can quickly grab the 7 and try to I want to see if there is a place where the 7 layers, or they were just taking them one by one. No. Okay, let's go back. You have to read a bit. Okay. So the lowest, the first and the lowest is the physical layer in the 7 layer of the OSI that we have. Now, the physical layer consists of the basic hardware transmission technologies of the network. Basic hardware transmission technologies of a network. That is what we call the physical layer. Basic hardware contains the basic hardware transmission technologies of the network. That is the physical layer. Okay, the physical layer defines the means of transmitting raw bits rather than logical data packet over a physical link, connecting network nodes. The bit stream may be grouped into code words or symbols and converted to physical signal. I think, please hold on. Okay, please guys, hold on. Click on examination page, that green text. When you click on it, you understand, it's going to load the protocol, the proto page where you will be captured to take you to, you understand. Just click on that examination page. The thing that loads next, you follow the instructions and then the thing will come up. That green text you are seeing, examination page. I'm sorry guys. I'm sorry guys, I'm trying to put someone through. Okay, let's move on. Sorry about that. So that is the physical layer. Why are we jumping so many? Somebody said we should just summarize and look for important things. That is why I'm jumping. I want us to get the 7 layers. So hold on, let me quickly get the 7 layers. I want us to get the 7 layers and explain them so that we will not be. Now let me explain them one by one. We have the physical, the easiest way. The easiest way to do this is let me share. Please let me share a file now. Let me share an MS Word file. I will stop sharing my screen now, because that, if you are to read what is in that material, is really not easy. Somebody said, but there is a way to quickly remember. There is a way to quickly remember. So let me share my MS Word page and quickly give it to us sharp for the sake of time. Now look at it. We have 7 layers. We have 7 layers. As soon as you are able to see, oh sorry, it's not yet showing. Hold on, it will show very soon. So please, once you are able to see it, you let me know. Once you are able to see it, you will let me know, so that okay, I think it's showing now, but I need to zoom it in a bit so that we can see what the content is. I want us to see what the content look like. Yes, it's making sense now. So physical layer, we have 7 OSI, that is open system interconnection layers. 7 of them. We have 7 of them. The first one is physical layer. And what is the work of this physical layer? It handles the transmission of raw bits over a physical medium. That is the main thing you should remember first about the physical layer. It handles the transmission of raw bits over a physical medium. It deals with cables, signals, voltage, and hardware. So the physical layer is basically concerned with the hardware, the ones we can relate to. And the example is the Ethernet cables, the switches. Those are just the basic level. Then the second layer, we have the data link. We have the data link. Let me take it. We have the data link as the second layer. First layer, physical layer. Second layer, data link layer. It ensures error-free transfer of data frames between devices on the same network. This is what we need now. Summary, because you just want to have an idea of what to write down in your exam. So the second layer, which is the data link layer, ensure error-free transfer of data frames. That is its own work. Error-free transfer of data frames between devices on the same network. That is just all you need to put down for them. The data link layer ensures error-free transfer. That is, it ensures accuracy of the transfer of data frames between devices on the same network. The accuracy of the transfer of, just like when we are talking about data communication, do you remember the characters? You remember accuracy is part of it. So data link is responsible for accuracy on network connections. So it handles the MAC addressing and error detection. Example of it, we have switches and MAC addresses. The third layer is network layer. The third layer is network layer, and the network layer is responsible for routing and forwarding data packets between networks. Routing and forwarding is for network layer, the number 3. Don't forget the first one, physical layer. The second one, the data link layer that we've mentioned, and then the network layer, which is the third one. This one is for routing and forwarding data packets between network. It uses IP addresses. Example is your router, your IP addressing, and the rest of them. Then the fourth one is transport layer. Transport layer. It ensures reliable data transfer between systems. This one is responsible for delivery. Just like in your characters of data communication, delivery is part of it. So we can just match it together like this and say that transport layer under the 7 layers of OSI is responsible for delivery. It makes sure that the data is delivered. Reliable data transfer between systems. It handles error recovery, flow control, and segmentation. Example is the TCP, which is reliable, and the UDP, which is fast but less reliable. That's example of transport layer. And then we have the section layer, which is number 5. It manages sections, connections between applications, and it establishes, maintains, and terminates communication sections. So the section layer is for section management, while we have the presentation layer, which translates data into a format the application can understand. Presentation layer is just like the transforming of data into designs that are relatable to the application. It handles execution, compression, and data formatting. Then we have the main and the last one, which the users are very close to. The one that the user use on their devices, which is application layer, is the closest to the user. It provides network services to the application. Example are the HTTP, the FTP, the SMTP, and web browsers. So that is the 7. If you want to remember them, if you want to remember the 7 layers, this is a mnemonic to help us in the exam. When they ask you, list the 7 layers, the 7 OSI layers. If they say list the 7 OSI layers, this is what you should use to remember. All people seem to need data processing. Then their first letter, the first letter of each word there represents a layer. All people seem to need data processing. The first letter of each word here represents a layer. So the first one, all, which is A, now is from, you know that the first one we'll talk about from bottom. From bottom is application. Going up is physical layer. So if you go from bottom, you are going down. Sorry, from bottom you are going up. You know that this is application. A, all represent application. The people represent presentation layer. Need all people seem. The seem represent section. the section layer. 2, transport layer. Need network layer. Data link layer. And then the last P is physical layer. So bottom up, going down from bottom up, remember this simple word to remember them. All people seem to need data processing. They all start for the application, the P presentation, the S section, the T transport layer, the N. The N now represents the sorry, why am I forgetting that N now? The network layer. Then we have the data link and the physical layer. All people seem to, let me drop that in the group so that you guys. Okay, I can see that I'm back now. Sorry, my network was having issue. I have to change the network. Can you hear me now? Can we proceed to the next thing we'll be doing? Are we good to go now? Can we proceed to the next thing we'll be doing? Okay, thank you. At least I've seen a confirmation. So let's continue, please. We just have like 2, 3 more topics that are important to cover. Once we've done that, we are good to go. So we want to talk about communication modes. That is the next thing we want to talk about. Don't forget the types of data we have, the type of data representation we have, the likes of. I think I'll need to share my screen back. Hold on, let me share my screen back so that you will see me. So we'll be talking about, what is it called now? Data. I am waiting for my screen to show on your side. We're talking of. Okay, sorry. I'm the one that. I believe my screen is showing now. Oh, sorry. I see where the error is. It's from my side. I was actually using. Okay, that means it's visible now. Fine. Let's go to data flow. That is the next thing they used to ask question on. Data flow. That is our concern. We've done all this one before. Data communication, the components, the data representation. Data can come in many forms, like in text, in numbers, in images, audio, video. That one is not something you should be reading. You know it. You know what data is. Everything you are doing on your WhatsApp every day is data. You send it. The video you send to your friend, data. The voice note you are sending is data. The text you are typing is data. Numbers and everything, they are all data. So that one we don't need to. We've done it already, though. So data flow. We've not done data flow. So let's quickly go to data flow and read about it so that we know that we have covered about 50% of what we are expecting in the exam. So data flow. Yes, let's read about data flow. What does it mean? How does it flow? We know what data means. And now communication between two devices can be simplex, half duplex, or full duplex. Let's start with that idea first. Communication between two devices can be in form of a simplex, half duplex, or full duplex. So if you are asked in the exam, the forms or the 3 ways in which communication can take place between devices, it can take place in simplex, in half duplex, or in full duplex. Then if you are asked to write short notes on each of them, let's now check the meaning of each of them. And then look at this drawing. We have the mainframe computer, which is the one feeding the data. Then the direction of data flow, and then the monitor receiving the data. This is simplex. In case you are asked to back up your answers with diagrams. The simplex is just the mainframe computer, which is known as the server, which is like the one giving out the data. And then you draw a straight line, which is showing data connection between the mainframe and the other device, which is the monitor in this case. And then you draw an arrow to show that this is how the data is flowing. It is flowing from the mainframe to the monitor, and that is a simplex. And now in simplex mode, the communication is unidirectional. That means it's only facing one direction. It's going in one direction from the mainframe to the monitor. That is all. As on a one-way street, only one of the two devices on a link can transmit, which means the monitor cannot send data back to the mainframe. It's only the mainframe. That is why there is an arrow that you have to indicate on your drawing to show that this is how data is flowing, not the other way around. Adibi is a two-way. Adibi is a two-way thing. You would have been like, you would draw the arrow from the mainframe and back to the mainframe. Okay, sorry, please hold on. So that is all on simplex. Data flows. The main idea you need to remember on simplex is that it's a unidirectional. That means only one direction. Data only flow from one of the devices connected and not vice versa. That is the main thing. Then the half duplex. In half duplex mode, each station can both transmit and receive, but not at the same time. So when one device is sending, the other can only receive, and vice versa. That is half duplex. For simple, only one can send and the other will be a receiver. For half duplex, the two of them can actually send and receive, but they can't do it simultaneously. When one is sending, the other will become a receiver. So it has to wait for the one sending to finish sending before the receiver can actually send anything it wants to send. So that is half duplex, and that is the idea. They both can send data, but not simultaneously. The half duplex mode is used in cases where there is no need to communicate or whatever in both directions at the same time. The entire capacity of the channel can be utilized. So it can be utilized in each direction. Now, for half duplex, this is it. You see the same thing. The station, but in this case, the flow of data is like this. It can go from this station and it can also come from this station. So that is just the idea. Don't forget that what you are doing now is data flow. That means how data flow from one device to another. The journey of data from one device to another. Oh, Fatima is not hearing me. I hope you can hear me now, because I've been talking since. So I hope you can hear me now. If Fatima is still there, I don't know if she can see me, because she said she was unable to hear me. So that is for half duplex. Then for full duplex, what's the difference now? For the full duplex, how does it work? In full duplex mode, also called duplex, both stations, okay, thank you. Both stations can transmit and receive simultaneously. Now, let's quickly summarize on data flow. Data flow has three types. It has the simplex, it has the half duplex, and the full duplex. Types of data flows we have basically. In the simplex, data only flow from one of the device, so the other one becomes a receiver. So you are going to have a mainframe computer, a monitor, then data flowing from the mainframe to the monitor. That is simplex. For half duplex, the two of them can send data and receive data, but they cannot do it at the same time. So if one is sending at the moment, the other one will wait and receive it first. After receiving it, it can send back anything you want to send. That is half duplex. For full duplex, both of them can send data to each other simultaneously, which means device A is sending data to device B And at the same time, while that is ongoing, the device B is also sending another data to device A, and device A is also receiving it. So a device can act as both receiver and sender simultaneously in full duplex. That is the idea you need to know, and you have covered data flow. Once you know that, if they ask you any question, it's just for you to now add simple tools or explanations to it. Now, the next thing we are likely going to go into under the most important topics that usually come out is protocols and standards. Protocols and standards. So let's go to that. And once I'm done with this, I will leave you guys to go and read on your own. Read meet. You are likely going to meet very high that they will come out. We don't know the exact question they will set on them, but that they will not come out is almost not possible. Now, protocols and standards. That is the last thing I'm taking with us. And then there are about 2 more topics remaining. Go and read that on your own before your exam. For protocols and standards, let's read what's protocol, what's standard. Don't forget that this course is all about data communication. This is all about principles of data communication, how data leave one device to the other, everything that is happening, both physically that we can see and the one that is happening in the virtual realm, that all that is concerned with the success of data leaving one device to the other. That's all this course is all about. So what are protocols? Let's start with protocols and get to understanding. So when I'm asking the exam, define the following terms: protocols, standards. What will I write there? What is protocol? In computer networks, communication occurs between entities in different system. Entity is anything capable of sending or receiving information. However, two entities not simply there are some errors here, cannot simply send bit streams to each other and expect to be understood. For communication to occur, the entities must agree on a protocol. A protocol is a set of rules, or is a set of rules that govern communication. It's as simple as that. Oh, my screen is just static. What you will do is the meeting, then join back. When you join back, make sure you place it on live so that it will not be showing you from back. When you join back, you just place it on live. That is it. Leave entirely, like leave the meeting, then join back. So for protocols now, in computer networks, two devices are communicating. If a device just sends something to another device, the device might not understand, what should I do with it? What is happening? Why did this one land? Why did this one come in? So protocols are rules that govern communication. It's simple as that. So when you're asked in the exam, define or write short note on the following. Protocol is a set of rules that govern the communication between devices. Now, a protocol defines what is communicated. Protocol is in charge of the following. Is in charge of what is communicated, that is the data that is being sent, how it is communicated, when it is communicated. So there are 3 things protocol serves to deal with in data communication or in communication generally. It serves as a guide to the thing that is communicated, how it is communicated, the channel to which it's going to be communicated, and then when, the timing. Don't forget the characters of data communication. That is the basic of what we did. The first topic we treated in this course is the basic of this whole course. It applies to every other thing we are doing. The characters of data communication, let me remind us again. We have the delivery, the accuracy, the timeliness, and the jitter. So those characters, they apply to every other thing we are doing. So protocol serves to be a guide to the way the data is communicated, or the data that is being communicated, the way it is communicated, and when, the timing, the timeliness. Now, there are some things that make the work of protocols possible. There are some things that make the work of protocols possible. For instance, if you are sending several data together, protocols will be the one to decide, should I send it alphabetically? Okay, which one will be easier? or let this set of data be sent based on their sizes, whether by the number of gig, the size, or should it be sent alphabetically. When it lands on the phone, should it be saved on the phone too alphabetically, or based on so protocol. Now, syntax, there are some things that the key element of a protocol, we have the syntax, the semantics, and the timing. The syntax is the one that refers to the structure or format of the data, the meaning order in which they are presented. So, for example, a simple protocol might expect first 8 bits of data to be the address of the sender, then the second 8 bits to be the address of the receiver, and the rest of the stream to be the message itself. So that is structure. The syntax is the structure, the format of the data. The semantics, the word semantics refers to the meaning of each section, how it is, or how is a particular pattern to be interpreted, and what action is to be that interpretation. So syntax is structure, semantics is meaning attached to each part of the data that is being sent. Let's just put that in mind. Syntax is the structure, the format. Semantics is the meaning attached to the data. While timing is the time frame it takes for the process to complete. So the term timing refers to two characteristics: when data should be and how fast they should be sent. When they should be sent and how fast they should be sent. So the timing is responsible for when and how fast, the speed, when and the speed. So under protocol, we've defined protocol as the set of rules that guide communication. Why there are key elements that protocol observes in order to become protocol. It observes the syntax, the semantics, and the timing. The syntax is responsible for structure and format. The semantics is for the definition, the meaning of each part of the data or whatever. While timing is the speed and when the data should be delivered or should be sent. So, having done that, we are done with protocols. Let's go to standards. Don't forget that the topic is talking about protocols and standards. So what are standards? What are standards? Standards are essential in creating and maintaining an open and competitive MAL equipment. Manufacturers and in guaranteeing national blah 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 blah. Now, standards provide guide to manufacturers, vendors, government agencies, and outer service providers to ensure, excuse me guys, who is this? Hello? Please go fast. I'm in the class. Please. What's the issue? Please call me back later. Sorry, please. Call me back later. That is not something I can answer. So, guys, I'm sorry. I am so sorry about that. My network went off. I had to answer the call. So I want to believe it to be back soon. Okay, sorry. I think my network is back now. Sorry about that. So standards, like we said, it provides guides to manufacturers and also all other users like government agency, vendors, and the rest of them to ensure the kind of interconnectivity necessary in today's marketplace and in international communication. Data communication standards fall into two categories: de facto, meaning by fact or by convention, and de jure, meaning by law or by regulation. I think the standard that's talking here is just like the general meaning of standard. Like once they set standard that this is the way data should be used, rules and regulation, laws that are guiding data. The difference between protocol and standard, let's quickly check now. What is the difference? The main, because they are very funny. What if they say you should write? No, how did they ask that question? Protocol. What if they say you should differentiate between the following words: protocol and standard? Differentiate between protocol and standard. All you need to know is that while protocol is just rules for communication, how the devices themselves they are communicating, the rules that guide their communication. Standard is official agreement. It's like an agreement. The protocol is also inside the standard, and it ensures conformity and uniformity everywhere, so that the way they are using this application in Nigeria should also be the way they are using it in US, should also be the way they are using it in any place. Is because of standard that have been set. So the difference, if you are asked to differentiate between protocols and standard, is that while protocol is just a rule of communication between the devices themselves, the standard is a governmental agreement, official agreement on how protocols should be observed to ensure uniformity in every place on the earth. That is that. And I think after that, don't forget, if they ask you the meaning of de facto or de jure, de facto means by fact or by convention. De jure means by law or by regulation. Those are the two ways standards take place. The standard take place by de facto and de jure. De jure, law; de facto, fact. It's very simple to remember. Say fact is the one that is de facto. Jure is the one that is law. You know, jurisdiction, anything that has to do with jury, they're all law. So jure by law. Then we have the standard International Organization for Standardization, the ISO, the International Organization for Standardization. They are the one in charge of putting together all of those standards. We also have International Communication Union Telecommunication Standard Sector, ITU/T. So what else do we have here? We have American National Standard Institute, ANSI, that ANSI. Those abbreviations, I think we should try to learn them by ourselves in case abbreviation will likely come out. Then IEEE is Institute of Electrical and Electronics Engineers. Institute of Electrical and Electronics Engineers. EAI is Electronic Industries Association. These are just standard organizations to ensure standards on the use of each of these protocols that have been put in place. Then we have forums. Telecommunication technology development is moving faster than the ability of standard committees. So in order to ensure that we don't have any shortfall, then they've created forums. We have regulatory and internet standards on their own. They are there. So quite a lot of things. Those are all just under regulations and standards of using connections or data communication protocols. So I think we've done justice to protocols. We've talked about the types of protocol of standards, de facto and de jure. We've talked about the element of protocol, syntax, semantics, and timing. That is in summary. So guys, I will leave you guys to go and read briefly on signal transmission. Go and read on network criteria, the performance, reliability, and security. You should read network, and then data presentation. We have done that already under communication. Another thing you should read about: security and cryptography. Security and cryptography. That one, they started asking that question recently. They asked it in 2024. They asked it in 2025. So we should likely expect it. This security and cryptography. Go and read it on your own. Go and read it on your own. So those are the only topics remaining that you have not covered, that you should go and read on your own, that you should be expecting in the exam. Security and cryptography, one. The network criteria, performance, reliability, and security. That is, then the signal and transmission. Go and read signal and transmission, analog versus digital signal, signal sampling, and attenuation. Once you have done that, you've covered the whole material. If you remove what we have done now and these two topics that I mentioned, if you cover them on your own now, you are done. You are ready for exam, and God will help us. So, guys, I wish us luck. I believe we'll do well. I'm just so sure of that. We'll do well. We'll do well. We'll do well. So, at least we know a bit about data communication, and what we know now, coupled with God's help, is enough for us to pass the exam. So I will leave you guys now so everybody can go and start using their time for something reasonable and also get to prepare one-on-one. Good luck, guys. So we'll decide when we'll do, after the exam today, let's decide when we'll study for tomorrow's paper. Bye-bye.